Good morning, grade 8. And then today we're going to continue on with 11.6. Today we're talking about circumference of a circle. I'm sure most of you have learned this before, but I'm still going to talk about it, and I want to make sure everyone understands circumference in the same way. Now, to start off, let me just quickly draw out a circle. It's not the perfect circle. Actually, I do have a tool that I can draw, I believe. Shapes, circle, there we go. There we go. There's a nice circle over here. So let me put the circle right here, and then let me continue. So here we have a circle. Before we start going into how to find the circumference of a circle, I want to write out some vocabulary that you all need to know. Vocab. Most of you know this already, but first of all, what is the circumference? Circumference. The circumference is the, well, I don't need is if I do that. The distance around the circle. It is the whole way around the circle. So if I start at this point right there, it is this whole distance going around like this, from point all the way to point. That is the circumference. Okay, so that is the first, so is the distance around the circle. Now, the second thing I want to talk about is the radius. Now, for the circle, let me just put a dot right in the center. I hope it's the center, or close to the center. I don't have a ruler, so it doesn't really matter. Let's just imagine that this is the center of the circle. Let me put a center. And so the radius would be the shortest distance from the center of the circle to anywhere of the side of the circle. So it's the shortest distance, which will mean it is a straight line from the center all the way to the side. So from here all the way to there, that is the shortest distance. From here all the way to there is also a shortest distance. From the center all the way to here is also a shortest distance. From the center all the way to the side is also a shortest distance. All of these are radius, and I would usually use a small r to talk about radius, a small r. So that's radius. The third thing I want to talk about is the diameter. Diameter. The diameter is the distance across the circle passing through the center. It has to pass through the center. So any distance across the circle passing through the center, so it would look like this. So this will be the diameter. Imagine I drew a straight line. Actually, I can use a straight line to do that. So I can do this. It's not passing there, it's passing through the center. Okay, so that will be the center of the circle. Okay, so that is diameter, and usually we use d for short for diameter. Okay, so this will be d. So now that we got the vocabulary out of the way, how do we actually find the circumference of a circle? So let's go here. Finding the circumference. So there is a simple formula that we use to find the circumference. So we use C for circumference, and this formula is equal to 2 times pi times the radius. And usually you would see it is 2 pi r without the multiply sign. I'm just putting the multiply sign so that you all know that it's multiplying together, but usually we write it as 2 pi r, where this is the circumference. This symbol over here is pi, and this is the radius. Now, just now, when you look back at this circle over here, the radius is half the distance of the diameter. So actually, there is a relationship between radius and diameter. Radius, or diameter, is equal to 2 times the radius, because radius is only half distance from the center to the side, whereas diameter is from one side all the way to the other side. So diameter is 2 times the radius. So since you see that there is a 2 times the radius, we can actually also write the circumference as pi times the diameter, or you can write it as pi d, where d is the diameter. Now, in case you don't know what pi is this super long number that looks like this. Okay, it is 3.1415926535897, and it goes on forever and forever. But since we're only approximating the circumference, we don't need to find the exact value. We can never find the exact value. Actually, this number goes on forever and ever, but I didn't copy all the numbers. It's impossible to copy all the numbers, actually. So we usually just approximate pi is equal to 3.14, and that's all we need to know. 3.14, the first 3 significant figures of pi. Or some people would choose to approximate pi by using a fraction. Pi is approximately equal to 22/7. So that's another way to approximate pi. Either 3.14 or 22/7, they are both good as approximates. Okay, so let's go straight into an example. Example 1. So we have a clock that is 25 centimeters in diameter. Let me draw a clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then it looks something like this. Let's say it's 12, 20, something like that. And so this clock has a diameter from here to here of 25 centimeters. Yeah, that's right. 25 centimeters. Okay, so let me write this down in words. We have a clock with a diameter of 25 centimeters. And then find the circumference. Why would we want to find a circumference? Maybe we want to decorate the edge of the clock with some tinsels or some color tape. I don't know. But we have to find the circumference. So how do we find the circumference? Well, we use the formula C equals to pi times d, pi d. because we already have the diameter. So we'll use c equals pi d. And all we have to do now is substitute in the numbers. So for this one, let's approximate it using 3.14. So c is equal to 3.14 multiplied by 25. Now for this chapter, for these two lessons, circumference and area of circle, I will allow you to use a calculator. You can use a calculator, put in 3.14 multiplied by 25, and you will get c is equal to 78.5 centimeters. Okay, so that's how we find the circumference. Now, let's do another example. Example 2. Now, let's say that a barrel lid has a radius of 21 inches, and we want to find the circumference. Let me just quickly sketch this barrel. It's a pretty big barrel with a radius of 21 inches. It's a pretty big barrel. Don't know what it's holding. Maybe it's some oil that's going to be transported to another country. Maybe. And so we want to find the circumference. Let's use this time we have the radius, so let's use the other equation. C is equal to 2 pi r. So let's put in all the numbers, and this time let's approximate it using the fraction 22/7. Okay, we want to try different ways of calculating circumference. So this is 2 times 22/7 times the radius, which is 21. Now we would see, conveniently, this question 7 and 21 cancels out. That becomes 3, and so c is equal to 2 times 22 times 3, which is 44 times 3, which is 132 inches. Okay, so that is example 2. We have one last example, and let's say this is a kind of like a word problem. So example 3. Let's say we have, for this one, sometimes we have to find the radius when given the diameter. Not given the diameter. Opposite. Find the radius when given the circumference. So this one we want to do it the other way around. So the scenario is a super large tree has a circumference of 1,231 inches by the tree trunk. And now we want to find the diameter. So let's this tree is pretty big. Maybe it's one of those large trees in the United States, something like that, in those big national parks. That doesn't really look like a tree, but this circumference is 1,231 inches. Okay, that's not a very good drawing of a tree. I'm not that good at drawing, but let's go into our equation. we want to find the diameter, so the circumference is equal to pi d. This time, let's plug in the numbers that we have. The circumference is 1,231 inches, and that is equal to, let's approximate it using 3.14. 3.14 times d. And how do we find d? I'm going to cross multiply by dividing 1,231 by 3.14, and so we have d is equal to 1231 over 3.14. Put that into your calculator, 1231 divided by 3.14, and you will have d is equal to 392.04 rounded up to 2 decimal places. Or if we want to round it to the nearest whole number, that will be equal to 392. So that is example 3. And that's pretty much our lesson today. So the homework for you will be the time you have all been waiting for, homework. You can find this on page 17 of the PDF, or it is on page 609 of the textbook. And so it is 11.6, exercise 11.6, and the questions will be questions 4, 6, 8, 11, 13, 15, 17, 19, and then question 20, 24, 26, and 30. Now, question 20 may be a little bit tricky. I just want to remind you, a full circle is 360 degrees. Let me make that bigger. One full circle has 360 degrees. I'm just going to put this here as a tip for you so that you can try and find out how to do question 20. Now, once you finish your homework, please take a picture of your completed homework and then upload it, insert it as a picture or insert it as a PDF into the homework section of class notebook. If you still don't know how to do that, watch the first video. I've shown you how to do that. Sign into your Microsoft BV account, CAIS BV account, and then please click on the link in your PowerSchool, and then you will be able to access the class notebook. You don't have to share the file with me because I already own the file. Some people are sharing it with me for some reason. You don't need to do that. Okay, so just upload a picture into the homework place and I will be able to see it. Okay, that's it for today, and see you all next lesson.